Hey guys, we're taking a look at station 3 and we're going to be working on inverse trig functions and looking up their values, okay? So in this we've split it up into two sections, 1 through 5 and 6 through 10. So 1 through 5, we are looking for inverse trig values in degrees, okay? And what that means is you're going to look this up on the circle, but you would do it in degrees, okay? So let's start with the first problem, okay? So for example, number 1. Okay, says what is the sine inverse of root 2 over 2? Okay, so that means I am looking for a sine value where it is equal to root 2 over 2. So the y value on the circle is root 2 over 2. Okay, so what I'm going to do is I'm going to say, hey, like here's my imaginary circle. Okay, and sine inverse has a domain restriction on this side. I'm not allowed on the quadrants 2 and 3. So there's only one coordinate where this statement is true. And that's right here, okay? And that point has root 2 over 2, 2 over 2, okay? So what we were looking for is this, the sine, to be root 2 over 2, okay, which is the y value. So what angle is that at? That is at 45 degrees on the circle. So the answer to number 1 saying, hey, what is the sine inverse of root 2 over 2? That is 45 degrees. In a similar way, we can do the tangent function. So let's take a look at number 2 real quick. We've got a tangent inverse of -1. So remember, tangents can only be one at either the 45 degree mark or the -45 degree mark. Okay, so over here, we again are going to block off these two quadrants because remember, tangent's domain is restricted on that side. Okay, so if you think about it, when the two x and y values are the same, that's when you can get 1. Remember, because tangent is y divided by x. So y and x are equal but opposite in sign. Okay, so we're going to be down here, okay, where we have root 2 over 2 and negative root 2 over 2. Okay, so this is when I divide these two because they're the same number, I would get -1 as my tangent. So what angle is this at? Well, it's 45 degrees, but it's downwards, okay? So we call it -45 degrees, okay? And that's really important. Make sure that you are not trying to say 315 degrees, okay? Because you're not allowed to go around the circle crossing through the restricted domain, okay? All angles in quadrant 4 are considered negative. Okay, let's take a look at number 3, which is a secant problem. Specifically, secants, cosecants, and cotangents are a little bit trickier because those are values that are not quite as obvious on our unit circle points, okay? But if the secant is negative root 2, okay, remember this actually means the same thing as the cosine is 1 over negative root 2, okay? And we can simplify this. 1 over negative root 2 rationalizes to negative root 2 over 2. Okay, so I can find a cosine value where this statement is true. Again, I'm going to think, what quadrants am I allowed to be in? I am not going to be down here in quadrants 3 or 4. Okay, so if I want my cosine to be a negative value, it's going to have to be over here on this side. Okay, and that angle is 135 degrees. Okay, remember cosine is the x value, so you're thinking of, hey, where would my x be? Negative root 2 over 2. It is at that 135 degree mark. So you can use this trick of flipping the fraction over to turn it into the reciprocal function that it goes with. That way you can find it easier, right? So cosecant can turn into sine, secant turns into cosine, and of course, cotangent can be turned into tangent by flipping it over. So if you put the number 1 over that, or flip your fraction over, you will get the reciprocal version. Okay, let's take a look at a couple of these in radians now. Okay, so it's the same concept. You're still looking for where the function's value is equal to that, like what angle it is, but we're going to do it in radians instead. Okay, so let's take a look at number 6. So in number 6, we have sine inverse of -1. So where does the sine value equal -1? So if we look at our quadrants, again, let's block off this section right here. Sine does not belong in quadrants 2 or 3. And sine is going to be -1 down here. This point is, of course, 0, -1, okay? And this point is at what we say is 3 pi over 2. But remember, everything in quadrant 4 is listed as a negative, so we call this negative pi over 2, okay? In the degree version, this is -90 degrees, okay? Very similarly, we can approach number 7, which is again a secant problem, right? So remember, secants and cosecants are the tricky ones. So secant inverse of -2√3 over 3. Let's flip it over to make it into a cosine function. So cosine inverse of -3 over 2√3. Ugh. This looks super ugly, but let's simplify that, and then we'll see that it's actually not as bad as it seems. Okay, -3 over 2√3 multiplied by √3 on top and bottom. Okay, -3√3 over 6. Reduce, and you get -√3 over 2. Okay, so this is cosine inverse of -√3 over 2. Okay, and again, this is something we can find from what we know on the circle, right? Okay, so again, block off the correct section. Hope you remember, cosine belongs in quadrants 1 and 2. It's a negative, it's got to be in quadrant 2. √3 over 2 is that lowest one there, right? So this is at 5 pi over 6. Okay, 5 pi over 6. Okay, so again, what we're doing, we are looking the values up from our knowledge of the unit circle and then stating the angle where that value exists. Each inverse only has a single answer because when you block off the domain, it takes away any duplicates. So that way you will know for sure that there's only a single answer possible. Okay, so each time you do an inverse, make sure that you block off a portion of your domain. Now, if you pause this video, I will put up the answers to the remaining questions as well, but go ahead and try them on your own before you look at the answers.